Okay. So just time to revise what all we have already learned. So I hope that you know the divisibility rule of 2.
Yeah, it's so any numbers that are any numbers that end with 0, 2, 3, 4, 6, and 8, like even numbers.
You should not end with 3. You said 3 as well.
Oh, 3, sorry. I'm at 4.
Okay. What is the divisibility rule of 3?
They should have a digital sum of 3, 6, and 9.
Okay. What is the divisibility rule of 4?
1 minute, can I use the bathroom real quick?
Yes.
Okay, thank you. Okay, I'm back.
Okay.
So for 4, yeah. So if the last two digits are 0, 4, 8, the number before that should be even. But if the last two digits are 2 or 6, the number before that should be odd.
Wonderful. Good one. What is the divisibility rule of 5?
The number should either end with 0 or 5.
Very good. What is the divisibility rule of 6?
It should be divisible by 2 or 3.
Very good. Do you know what is the divisibility rule of 9?
9. Like you didn't teach me it, right?
Yeah, I didn't taught you. So let's write the table of 9. So 9 into 1 is 9. 9 into 2 is 18. 9 into 3 is 27. 9 into 4 is 36. 9 into 5 is 45. 54, 63, 72, 81, 90, 99, 108, 117. Just find the digital sum. Tell me how much it is.
Oh, 1 minute. Let me just get this down. Wait, what? Okay, sorry. The digital sum. What? 9. And then that one is 9 also. And 9. Yeah, so it's keep on repeating 9.
So what does it mean? The digital sum is always 9.
Should I write the final?
Yes. A number is divisible by 9 if the digital sum is 9.
Okay. Oh yeah.
Okay. When can you say the number is divisible by 11?
11? Like the divisibility rule of it, kind of.
Yes, yes. Divisible to rule of 11.
I'm not sure.
Okay.
Wait.
So write down and then we will understand. A number is divisible by 11 if the difference between sum of alternate digits is multiple of 11. So there are two words in mathematics, one is consecutive, one is alternate. Consecutive means just next to it, alternate means after one. You can ignore one. So you tell me any 5-digit number.
Okay. 3, 4, 5, 3, 9.
So if I ask you about the alternate digits, the digits at the place values of 1, 3 and 5. So these are alternate digits. Similarly 4 and 3 are alternate digits. So we have to add and find the difference between the sum of alternate digits. So 9 plus 5 is 14. So first we will add the digits at the place of 1, 3 and 9. 1, 3 and 5. So if I add them, I will get 17.
Yeah.
If I add these digits 4 and 3, I am getting 7. So we have to find the difference. If the difference is a multiple of 11, then it can be divisible by 11 or it will not be. So 17 minus 7 is how much?
10.
So is 10 divisible by 11?
No.
So this number is also not divisible by 11. So what should be changed? So if I change this 9 to 8, for example, if I make this 9 to 8, what it will become? 3 plus 5 plus 8. Now add them, so you will get 16. No, I think it should not be. So this we can make 6. Okay, this number I am increasing by 1. So if you add 3 plus 6 plus 9, you will get 18 now. And again 4 plus 3 is 7. So if you do 18 minus 7, it is 11. Now you will find that this number is divisible by 11.
Yeah. Wait, can I write this down real quick?
Yeah.
Min first focus group, our right group. Okay, done.
Now you see 3, 4, 5, 3, 9. If I am dividing it by 11, I will get the answers in decimals.
Yeah.
But if I divide 3, 4, 6, 3, 9 divided by 11, I am getting a full whole number. That means it is divisible, exactly divisible by 11. Are you getting it? So
Yeah.
whenever you see numbers, what you can do, you can add the alternate digits and just find the difference if that number is divisible by 11 or not. Alright?
Yeah.
Then there is a trick for multiplication of 11 by a number. For example, 2-digit number. Suppose I multiply 11 by 23. So do you know what could be the answer?
Like, no.
So you just need to add 2 plus 3. So 2 plus 3 is how much?
5.
5. So just write 5 in between them. Okay?
Oh, okay. So you just do that for every single time you multiply by 11?
Yeah. So, for
Oh.
example, suppose I ask you what is 11 times 72. Tell me.
7, 9, 2.
Wonderful. You can check as well.
Oh,
Okay.
yeah. Okay.
Again, let me show you 11 times 54. Tell me.
5, 9, 4.
Easy. Now, suppose
Yeah.
what if the sum of these two digits is greater than 9? Suppose I give you 11 times 74. Now, what will happen? So, write 4 as it is. 7 plus 4 is how much?
11.
11. So, write 1 and keep 1 in your mind. That 1 will be added to 7. So, 7 plus 1 is how much? 8.
8.
So, you can check 11 into 74.
Okay.
Alright, shall I give you some numbers more?
Yeah.
So 11 into, tell me what will be 59.
Okay. 6, 1, 4. Wait.
Let us check.
Oh, wait. Oh, yeah.
So 9 plus 5 is 14.
Yeah.
Okay. 9 plus 5 is 14.
4.
No, wait. The last, 4. And the last digit will be 9 only, and 1 will be added to 5. So make it 6. So 649. Alright.
Okay. Yeah, I got it.
Let us check 11 into 75.
Wait. Oh, yeah. 8, 2, 5.
Very good. 11 into 98.
Oh, 1, 0, 7, 8.
Wonderful.
Okay. Can I write this down?
Yeah, please write down.
Okay.
Done.
Yeah.
So you can see that divisibility rule of 2, 3, 4, 5, 6, 9 and 11 is done now. Now you remember the prime numbers?
Yeah.
Okay, now start.
Yeah.
Time starts now. Ready? Go.
2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97.
Wonderful. Good one. Good. Just keep repeating these things over a period of time. What about the composite numbers? No, before composite numbers, I would like to understand whether you remember these exponential values. What is 3 to the power 6? 729. Okay, what is 2 to the power 12?
4096.
Wonderful. What is 5 to the power 6? 15625. What is 7 cube?
7 cubed.
343.
Yeah.
What is 3 to the power 5?
293.
243. It is 100 less than 7 cube. Okay. What is 8 cube?
512.
Wonderful. Suppose I ask you 2 to the power 10 multiplied by 5 to the power 6. Tell me how you will do.
You would break up 2 to the power of 10 into 2 to the power of 4 and 2 to the power of 6.
Wonderful.
And then
you will get 16 times 10 to the power 6. Good one.
Okay.
Very good. Now, do you also remember the prime factorization of the composite numbers?
like I still need I know how to do it and everything, but I still need like practice on
Okay. So just
calculating it.
just keep practicing. Start writing down. Can you tell me what will be 64? See, what will be 64? Prime factorization of 64.
64. 2 to the power of 3 times 2 to the power of 3.
Why don't you say 2 to the power 6?
Oh, yeah, you can do that too.
What is the prime factorization of 81?
But wait, is there like any, would 2 to the power of 3 times 2 to the power of 3 be wrong? Like, does it always have to be 2 to the power of 6?
No. 2 to the power 3 times 2 to the power 3 is right only. See, if I ask you, what is 2 by 2? So you might end up by saying, sir, it is 3 by 3. Sir, it is 4 by 4. Sir, it is 100%. Sir, it is ONE. There are lot many ways to say a thing, but the actual answer is 1.
1.
So the same number can be said in many ways, but you have to think yourself what should be the actual way of saying it. Okay, suppose your mom sent you to the market to buy 1 kg of potato. Okay, or she asked you to buy 1.5 kg of potato. So do you love to hear 1.5 kg of potato, or do you love to hear bring 3 by 2 kg of potato? Tell me, what you will love to hear, this one or this one?
1.5 kg.
So we also love to hear 2 to the power 6.
Yeah.
Rather than saying 2 to the power 3 multiplied by 2 to the power 3. This is not the simplified way. This is the simplified. This is not wrong. This is also not wrong. But we love to hear this.
Yeah.
Alright?
Okay. Yeah.
Okay, so prime factorization is also done. Now today we will try to learn the squares and see the magic of squares in the real world. So we will start with, tell me up to what number the squares you already know.
Of squares, like,
so 1 into 1 is a square, 2 into 2 is a square. Square of numbers.
Then 10, I think.
Okay. But before that I would like to see whether you know about some basic properties or not. Okay. So I taught you, I think, one day closure property. You remember the closure property?
Closure property? Can you like explain what it is?
So closure property was on 4 kind of numbers: natural numbers, whole numbers, integers, and rational numbers. And we
that would start a class, right?
addition, subtraction, multiplication, and division.
Yeah.
So there are 4 operations and 4 kind of numbers. So if you add it to natural numbers, you will always end up in getting a natural number. When you multiply 2 natural number, you will add up in getting a natural number. But when you subtract 2 natural numbers, you will not get always a natural number. Because if I do 1 minus 2, we will get minus 1, which is not a natural number. So we say that natural numbers are not closed under subtraction. So neither closed under division as well. Now for whole numbers, if you add two whole numbers, will you always get a
can I just write this down real quick because I'm gonna just have it as a reference.
Okay.
You can keep going. I'll just be writing down.
Okay. So if I ask you about the whole numbers, you will see that whole numbers, you keep adding whole numbers, you will end up in getting a whole number. Multiplication as well, but not for subtraction and division. For integers, you will find that all the numbers are closed under subtraction as well, because the range of integers keeps on going up to negative infinity. But for division, it is also not closed. Same goes with the rational numbers, because division by 0 is not allowed. So you cannot say that the rational numbers are closed under division as well. So none of the number are closed. This is a very beautiful property. Suppose you are getting a number and you are getting another number multiplied, and the difference, suppose this is an integer, this is also an integer, and you have got four options. One option is 1.1, one option is 1.2, one option is 1.3, one option is 1.0. So you think that integers, when multiplied by integer, you will get an integer. So these options can't be the answer. So this is the right answer. So when you multiply two things, if the answer is the same kind of thing, same kind of number, we say that those things are closed under those operations. So if it is right, we say that, what we will say for this? We will say natural numbers are closed under addition. Natural numbers are closed under multiplication. Natural numbers are not closed under subtraction, neither closed under division. Understood? This is the first property in mathematics. There are 6 basic properties which you have to remember. The first is closure property. Now coming to the second property, which is commutative. Do you know what is commutative property?
Yeah, it's like no matter how you add it, it's always going to be the same answer.
Okay, it works for only two numbers. So you say that a plus b is equal to b plus a. Also a multiplied by b is equal to b multiplied by a. But a minus b is not equal to b minus a. Similarly, a divided by b is not equal to b divided by a.
Yeah. Okay.
Understood?
Yeah.
So this is known as commutative property.
Yeah.
Okay. Now how it is being helped? Where is this property is used? So suppose I give you a number. Let's play a game. So I will give you one number, you have to tell me another number. The sum should be 100. For example, if I say 64, you have to say 36. Okay?
Okay.
72.
18. No, 28.
28. Good one. 77.
77, 23.
Wonderful. 82.
18.
65.
35.
Very good. 54.
46.
Wonderful. Now my question is, suppose you have been given these numbers to add 72 plus 34 plus 28. So what should be your approach? Can you tell me the answer immediately?
Yeah, 134.
So that means what you did, you added these two numbers first because they are making 100. So accidentally, rather than doing 72 plus 34, you are doing 72 plus 28 plus 34. So you commuted these two numbers. You did commutation of these two numbers. Are you getting it?
Yeah.
So this
I
is,
just started.
yeah. So this is where commutative property is used.
Okay.
Now sometimes you see the numbers like this, 25 times 64 times, let us say 4. So what is the first one, or let us say this is 25 times 125 times 4. So which two numbers should be started to multiply first? So you should multiply 25 by 4. How much it is? 100. So you can easily find the answer. So numbers should be chosen in a way so that you get to form 10, 100 or 1000 or something like that. Are you getting it? So this is how you should multiply using the commutative property. All right.
Okay. Yeah.
Then there is a third property which is known as associative property.
Yeah.
So associative property says that three numbers can be added in any order and multiplied as well. So nobody in the world has taken birth who can add three numbers at a single time. Okay, nobody can do that. Nobody is that born who can add three numbers at a single time. They will always take two numbers, add, find the result, and then add the next number. For example, suppose I say 2 plus 3 plus 8. So
Yeah.
how you are going to add them? So either you will do 2 plus 3 first, and you will say it is going to be 5 plus 8, which is going to be 13, or you can do 2 plus 8 first and tells her it is going to be 10 plus 3, which is also going to be 13, or you can do 2 plus, you can first add 8 plus 3 first, and then you will say it is going to be 2 plus 11, which is 13. So any of these three methods you can use, but nobody in the world can dare to add all the three numbers in a single way. No, that can't be happen. I haven't found anybody. Okay, so you can't say 2 plus 3 plus 8 is 13. No, nobody can say that. First they will say 2 plus 3, they will make up their mind with 5, then they will add 8 to get 13. Or they will add 2 plus 8, 10, and then add 3 to 8 to get 13. So the only way that you can find the addition is you take two numbers at a single time. So whose two numbers you are taking it, what two numbers you are taking it, you put them into a bracket first. To show that this is the rule that I am following. First I am solving the bracket. So the putting up of bracket is known as associative property. Which two numbers you decide first? All right?
Yeah. Yeah. Can I write this down real quick?
Yes, please. The same property works with the multiplication as well.
Yeah. Oh.
Done?
Yeah.
Then coming to very important property, distributivity of multiplication over addition.
That's just where you like distribute one number among many numbers, right?
Yes.
Right.
So this is the most used property in mathematics. You multiply any two numbers, you do that with the help of this distributivity property of multiplication over addition. Now I will be asking you some questions. Suppose I ask you to multiply 25 times 64. Can you tell me what is your approach? Not with the exponential one, but how you do it earlier before my classes.
Oh, so first I would do like 5 times 4.
Okay.
That is 20. So then I'll do 4 times 2, which was 8. Then I would do 6 times 5, 30. Then 6 times 2. Then I would just add all those numbers up that I just wrote.
Okay, no. First tell me what should I write below this number 0?
0.
Okay. Then?
Wait. Hold on. What? What do you... I don't understand what you're doing right
No,
now.
I am also not understanding what you are saying. So first I have wrote 100. I multiplied 4 by 25. That's fine. Now tell me the second step. What should I do now?
Oh, I never did that. Like, that's not my step that I did.
Then how you do? How you do? Tell me.
Oh, wait. Are you asking how I usually do, or if I do 4 times 25, what's the next step?
Yeah, after multiplying 4 times 5, after writing this 100, what's the next step?
Oh, okay. Then, after doing 4 times 25, I would probably just do... What? This isn't like the way... Huh. Do you want me to do how I usually do? How you do? Okay.
Yeah, that's
then
what I'm asking you.
Oh, okay. So look. First, I do 5 times 4, 20. Then 4 times 2, 8. Then 6 times 5, 30. And then 60
So
times
no,
2.
where should I write 30? Where should I write 0? That's what I'm asking you. You said
So
6 times 5 is 30. So where should I write 0? I should write here, here, or here. Where should I write?
you have to write... Wait. Oh, you have to write like under the last 0.
This one?
No.
This one. Okay, I am
all the
writing
way to
0
the
here.
end.
Then what should be the
Yeah.
next number written?
3.
3?
Next is 0. Yeah.
Next is?
Under that. What? No, under. Oh wait. Huh?
You do one thing. You multiply this in your notebook and tell me all the 2 rows that what you have written. Tell me all the 3 steps. I want you to tell me the first step, the second step, and then the third step. Okay? Do it in your notebook first. Let's not create some confusion. Please do in your notebook and then tell me what you have done.
Okay. Yeah.
Done?
Oh, no, wait. Pause. Yeah, okay. This is already. Okay, so what is the next? It's not 100. No, it's not 100. So, like, those numbers, they're wrong. So first, after doing 5 times 4, I got 20.
Okay.
So, first 20.
I should write
Then
20?
next, yeah, 20.
Okay.
And then under that, 80.
Under that 80.
Yeah.
Okay.
And then 300. But like, the 2 zeros under 80, then 3 next to the left of the.
Okay. This is how you're doing it?
Yeah, and then 1,200.
And then after that 1,200.
Yeah, that's all. Then I add it.
Okay. So you will get 0, 0, 6, 2.
Yeah. Wait, what? What?
No, 1,600.
1. Yeah, 1,600.
5 times 4, 10 times 4. Okay, can you tell me how you got 4 times 5, 20? This is you are multiplying 4 times 5. How you
What do you
got
mean how?
from where you got 20? Can you tell me from where you got 20?
Oh, so from 20, I first did 4 times 5 above.
Okay,
Then for 80.
How you got 80?
80, I got 4 times 2, but that's 20. So just
Okay, then
4 times. And then for 300, I did 60 times 5.
okay,
And for 1,200, I got 60 times 20.
okay. So 60 you are getting from here and 20 you are getting from here. This is how you do?
Yeah, that is how they do. Yeah.
Okay, good one. So which property is allowing you to add them? Tell me how you are adding them, why you are adding them. This is my question. You are multiplying these numbers, fine. Now my question is why you are adding all these 4 numbers? Who told you to add the numbers to get the final answer?
I mean,
Or this is the way that is being taught to you?
this is the way that has been taught to me.
So you know why this is working, why you are adding all these numbers. See, you were being asked to multiply 25 times 64, but you broke down into 4 different parts. You said, okay, I'm going to multiply 4 times 5, then I will multiply 20 times 4, then I'm going to multiply 60 times 5, then I'm going to multiply 60 times 20, and then I'm adding them.
Yeah, that's commutative property, right? Commutative property.
No, that is not commutative property. So that is the distributive property. Okay, now see, if I ask you to add 4 3 times. Suppose I ask you what is 4 plus 4 plus 4. You can write it as 3 multiplied by 4. Are you getting it?
Yeah.
Suppose I ask you what is 5 plus 5 plus 5. You can say it is 3 times 5. Right?
Yeah.
So if I ask you 25 times 64, you can say it can be 20 plus 5 times 60 plus 4. Can you do like this? Okay. Now see what you did. First you, or rather I should write in a different way. I will write 5 plus 20 times 4 plus 60. This is exactly what you did. First you multiplied 5 times 4. to get 20. Then you multiply 20 times 4 to get 80. Then you multiplied 5 times 60 to get 300, and then you multiplied 20 times 60 to get 1200, and this is all what you are doing. The same thing which is being vertically downwards is also done horizontally. So this property is known as distributivity of multiplication over addition. We were asked to multiply two numbers, we distributed them into the sum of two numbers, and then we multiplied. So multiplication over addition. The multiplication has turned up to addition. You can see that we are adding something, but how we are adding? We distributed the number that were to be multiplied into the addition of two numbers. Are you getting this? So how this property works, you should understand in a algebraic way, and that is very important. Suppose I ask you x plus a multiplied by, let us say, y plus b. X plus a is going to be multiplied by y plus b. So x and a are different numbers, y and b are different numbers. So how these numbers are multiplied? So first x is multiplied by y plus b. First x is multiplied by y plus b, and then a is multiplied by y plus b. Any doubt?
No.
Now x is multiplied by now each and every part, so you will have xy plus bx. From here you will get ay plus ab. These are the four terms that you will get. When a two-digit number or two numbers are multiplied by another two, sum of two numbers, you will get the four products. The same you have shown here. Alright, so this is known as distributive property. You can write down.
Okay. Okay. Got it.
Done?
Yeah.
Okay. So using this distributive property, we are going to form four algebraic identities as well. The first one is x plus y whole square. Okay?
Yeah.
So which can be written as x plus y into x plus y. So now, as per the previous learning part, can you tell me what should I write? What should be the next step?
Okay. So wait. For the x plus y times x plus y, right?
Yes.
So we have to do x times x plus y.
Wonderful.
And then y times x plus.
So you have to say plus y times.
Oh, yeah.
Okay. What should be the next step?
And then after we got those two, we have to like add them together.
Tell me, what should I write?
X plus x plus
Okay, so
x.
x can be said as x square.
Okay, x is squared
Okay,
plus xy
okay,
plus yx
wonderful,
plus y squared.
wonderful. So these xy and yx are like terms. They can be added because they are xy same only. So you will have x square plus 2xy plus y square. This is your first identity. Write down.
Okay.
This is first algebraic identity. So written.
Yeah.
Then comes the second identity, which is x minus y whole square, which is like x minus y is multiplied by again x minus y. Now you tell me, what is the first term that I will write? How we are going to perform? First step.
So first we multiply x and x to x minus y.
Very good.
Then we multiply y to x minus y.
No, don't say y. Say minus y.
Okay, x minus y.
So minus y will be multiplied by x minus y. You have to take the sign convention. This minus 5 is coming here.
Yeah. Oh yeah.
Then tell me what will come.
Then we do x squared minus, right?
Yes.
X minus y.
No.
Wait, isn't it x minus y?
No, x multiplied by minus y is minus xy.
Okay.
If I say 2 multiplied by minus 3, you don't write minus 32. It is how much? 3 into 2 is how much? 6. But in case of x and y, we don't know the values, so it will remain xy only. So x into minus y is going to be minus xy. All right.
Yeah.
Then next.
Then minus yx.
Very good.
And then minus y squared.
Minus y into minus y will be plus y square. I hope that you know the multiplication of values.
Yeah.
Okay.
Plus.
So the final answer will have x square minus 2xy plus y square. This is the second identity.
Okay. Let me write this down.
Yes.
Okay.
Okay.
Yeah.
Okay. So where it is being used, let me show you. So just by looking at the instant, can you tell me how much will be 51 square?
Hmm?
If I ask you what is 51 square, can you tell me immediately?
No.
But with the help of this identity, you can tell immediately. Let me show you. So 51 square can be written as 50 plus 1 whole square. Alright.
Okay.
So what is x in this case? Can you tell me what is x in this case?
50.
What is 1 in this case?
1, 1.
Very good. So x square is how much? 50 square is how much? 2500. Alright.
Okay. Yeah, wait.
Now,
I think I need a little more practice on this. Can we go over it a little more? Because I didn't fully understand. But,
what you didn't understood? You didn't understood this property?
no, I did. I just didn't understand how you got 2,500.
So 50 see x is, you said x is 50.
Hmm.
So 50 times 50 is how much?
Oh, yeah. Oh, I was looking at, like, I got confused with all the other steps because
No,
there
no,
were.
no, no. I am just asking you. See this focus here. X plus y whole square. This is the end result. X square plus 2xy plus y square. Now you have to focus here. We know that this can be. We can get this by these three steps. Now focus here. I am telling you what is x. You said 50. So my question is, what is 50 square? 50 times 50 is how much?
2,500.
Very good. Now you have to multiply these two numbers and double it. So what will be 2 times 50 times 1? Tell me.
2 times 50 times 1. Like
2 times 50 is how much?
100.
100.
And then 101.
So what is 1 square? 1. So how much you are getting?
101.
260. All right, let me show you.
2
See this.
Yeah.
Now, don't write. Wait.
Okay.
First understand. I will give you the time to write. Now let us suppose it is 52 square. So what will change? Tell me. It will become 50 plus 2 whole square only.
Yeah, that's fine.
So 2500 will remain as it is.
Yeah.
Now 100 will become 200. And 2 and 1 square will become 2 square. Just try to see the change. What is the change? The answer is 2704. Now see the pattern. The pattern is that this number 1 and 2 is always added to 25. See this, 25 plus 1 is 26. The first two digit, focus on the first two digit. The first two digit depends upon how much this number is greater than 50, that much is being added to 25 always, because 50 square is always going to be 2500. It is not going to change.
Yeah.
All right. Suppose I ask you what could be 53 square. So can you tell me from this pattern that what will be added to 25?
300 and
So don't say 300, just say 3, because 100 we have estimated. These two numbers are not going to change. This will not make any difference. 0 and 0 will not add up to anything. So 25 plus 3, 25 plus 1 was added, then 25 plus 2 was added, then 25 plus 3 will be added. So how much you will get? 28.
yeah.
And the last two digit will be the square of 3. So square of 3 is how much? 9. So you will write in a two digit number. So 2809. Just check it out.
Oh,
Okay. Now tell me, what could be 54 square? What should be added to 25? Tell me.
so 400. So it would be 2,960.
Wonderful. Just say this.
Oh,
Can you tell me what will be 55 square?
55, 3,025.
Wonderful. Say this. Can you tell me what could be 56 square?
Okay. 3,136.
See, now you are super fast. Can you tell me what will be 57 square?
57. That would be 3,249.
What could be 58 square?
58. Oh, yeah. That would be 3,364.
What will be 59 square?
3,481.
You can check as well. 57 into 57, see 57 into 57, 3249, 58 into 58, 3364, 59 into 59, 3481. All right, now write down.
Okay.
I hope you understood the property
Yeah, I understand.
and use as well. Where to use?
Yeah.